Hello everyone. Today I'll be going over the Pythagorean Theorem. So it'll be my first video here on trigonometry. And for this trigonometry video, it'll be the first of the series where I'll be going over the full extent of trigonometry for different levels of education. And everything you'll need to know will be in that series. So let's get started. What is the Pythagorean Theorem? The Pythagorean Theorem. The Pythagorean Theorem starts with a formula. The formula is a squared plus b squared is equal to c squared. So this is the formula. Then we have its application. And just like I just mentioned, the application is in regards to trigonometry. So here, let's say I have my triangle. And the key point here is that when you're using the Pythagorean theorem, you must be working on a right angle triangle. Now, what is a right angle triangle, you might ask? A right angle triangle is a triangle that has a right angle in it. And a right angle is a 90-degree angle. And it is denoted by this square here. So here is my right angle, my 90-degree angle. And what these letters here symbolize are the unknown lengths of these three sides. So C is always going to be here, the longest side. And the way you can find this side is that it's always opposite to the 90-degree angle. Then, it doesn't matter which one we pick for A and B, but we can choose them however we like. So let's say I want this one to be A, and I want this one to be B. It makes no difference in the equation. So let's say I pick this A, I pick this B, and I pick this C. I need to know two of these three unknowns. So my three unknowns are, first one is A, second one is B, third one is C. I need to know two of these three in order to complete the equation. So let me give you an example. Let's say I want to find this longest side. I am going to set it, well, the equation is already set as equals c squared, so I'm going to try to use what I know about A and I know about B to find C. So let's say the question includes that A is equal to 6 centimeters and that B is equal to 3 centimeters. And then their question is, what is C equal to in terms of length? So what we do is we simply sub in these numbers here, 6 and 3, into the equation. So what does that look like? Let's do it right here. We have 6 in place of the A. So we have 6 squared plus 3 squared, because the B is equal to 3 centimeters, is equal to C squared. Okay, what is 6 squared? And if you're not familiar with the squared or the exponents yet, I highly recommend that you check out our videos in regards to going into exponents, all their extent. It's already made as a playlist on my YouTube channel, so if you want to check it out and understand more about it, then you can check those videos out. Okay, so what we already know is 6 squared is equal to 6 times 6 plus 3 squared, which is 3 times 3, is equal to c squared. Okay, 6 times 6 is 36, plus 3 times 3, which is 9, is equal to c squared. So we simply do this addition here. 36 plus 9 is equal to 45. And then here, what is the opposite operation of square? It is the square root. So we take the square root of both sides to isolate for c, because that's what we're trying to find here. And since the square root of 45 is not going to give us a nice answer, I'm just going to leave it as the square root of 45 centimeters. So if I were to do the square root of 45 and simplify it more, let's say, evaluate the square root, I would get somewhere around 6.7 centimeters. Notice how I know this is right, because it is larger than the other two sides. Perfect. Let's go on to do another example. Let's see, where's my eraser? There it is. Okay. Now, what if instead of knowing A and B, we were given C is equal to 8 centimeters and B is equal to 4 centimeters? The question is, what is A? So this formula does not change. All we have to do is rearrange it so that we're solving for a squared. And then we would simplify or isolate for a. So in this case, it would look like this. We would move the b squared to this side, put everything we know on one side and all the unknowns on one side. Which is going to be a squared is equal to c squared minus b squared, because once we move the plus b squared to this side, it switches signs. All right, let's evaluate that. So we sub in our numbers. We have a squared, which we don't know, so a squared is equal to, we have 4 squared minus 8, oops, I switched up the numbers. So here we're putting in c, so we're putting in 8 squared minus 4 squared, and we already know what those will give us. 8 squared is 8 times 8, which is 64, minus 16, since it's 4 times 4, so minus 16 is equal to a squared. Then we simplify it even further. 64 minus 16 will give us 48. And then to get rid of this square here, we take the square root of both sides. We're left with the square root of 48. Now if we were to find the approximate answer for this, it'll give us 6.9 centimeters approximately. And that would be the side of A. Now notice how it's not larger than C. It doesn't matter whether it's larger or smaller than B, because those are interchangeable in terms of their lettering. But C is the longest side, and here the rule holds true. All right, let's do some more examples. Oops. So what if instead of having a triangle that looked like that, what if we had a triangle that looked like this? Since this triangle here doesn't have a right angle triangle anywhere here, we cannot use the Pythagorean theorem on it. Since this triangle right here doesn't have a right angle on it, we can't use this either. It has to be exactly 90 degrees. So let's say it's like this, and then I put in the square, which tells us that it's a 90-degree angle. Now I can use this. Now, which lettering am I going to use for this triangle's sides? Let's say I want to use this as A, this as B, this as C. Remember, C is always the longest side. And so in the equation, it will be a squared plus b squared is equal to c squared. And even if I switched up the lettering, if I made this one x, this one y, and this one z, z would have to be in place of the c, y in place of b, and x in place of a. These two are interchangeable, the x and the y. However, we can't play around with the other side because that must be the longest side. Okay. Now let's give ourselves some unknowns and we'll try to solve it together. Let's say we know that, let's see here. We don't need this version. I think the a squared is fine, and the b squared is fine, and the c squared is fine. Okay. So let's say I'm given a squared, or a is equal to 36. And c is equal to 45. Let's say the unit is in meters. And then the question is, what is the length of side B? Okay, now to solve this, we simply have to put in the numbers that were given into the equation. So here we'll be given 36 squared plus b squared is equal to c squared, which is 45 squared. So what is 36 squared? That is 1,296. I just used my calculator. Plus b squared is equal to 45 squared, which gives us 2,025. Now to isolate for b squared, we have to move this number to this side, therefore switching its sign. So we're left with b squared is equal to 2,025 minus 1,296. Now let me just quickly move this over to the middle. Perfect. Okay, this was 36. Okay, now in here, to simplify it, we simply use the operation. So we do 2025 minus 1296. That leaves us with 729. Now, to isolate for b by itself, we have to take the square root of both sides. So once we do that, this squared is gone, and we're left with b is equal to the square root of 729, which is equal to 27, because 27 times 27 is equal to 729. Therefore here, if they asked us what is side b equal to, side b is equal to 27 meters. Although this was just the introduction to the trigonometry series, I'll be going over some more applications of this in regards to real-life examples, examples you'll see in your classroom, depending on what level of education you're at, and it'll be a series on the full extent of trigonometry from elementary school all the way until the first year of university. But for now, I'll see you next time.